So nucleophiles are a kind of species which are electron pair donor. They are electron rich. So how you will figure out whether nucleophile is present or not? You just check whether a lone pair is present on the central atom or negative charge is present. If negative or lone pair is present, that means it is a nucleophile. So they are nucleophiles are electron pair donors. They are Lewis bases and they could be negative or lone pair containing species. Alright. So we have over here all negative species are nucleophiles, Cn minus, OH minus, NH2 minus, RO minus, Cl minus, Br minus, I minus, F minus, SH minus, acetate ion, all these are negative species and they can act like a nucleophile. Alright. And second category is neutral species where lone pair is present on oxygen, nitrogen, phosphorus, something of this kind. We have few examples over here. These are all the nucleophiles where lone pair is present on nitrogen. These are nucleophiles where oxygen is containing lone pair, sulfur containing lone pair, phosphorus containing lone pair. So lone pair is present, that's why all these are nucleophiles, right? Next, if we have to figure out a pi bond containing species is an electrophile or nucleophile, then you will have to see if pi bond is present between different atom or same atoms. For example, I have sulfur trioxide, CO2, and I have alkene, CH2 double bond CH2. I have CH3CH double bond CH2. I have benzene. So what do you think? Here we have pi bond between different atoms. In these two we have pi bond between different atoms and here we have pi bond between same atoms. So just remember this, if pi bond is present between different atoms, they are electrophiles. If pi bond between different atoms, they are electrophiles. What happens is one of the pi bond here can be actually seen in polarity sense. What you will see that in oxygen partial negative and on sulfur comes partial positive. So this becomes a electrophilic center. Sulfur becomes an electrophilic center here, and here in carbon dioxide you have partial negative on oxygen and partial positive on carbon. So one pi bond will break and this carbon will become a positive carbon and will act as an electrophilic center. Here sulfur will act like a electrophilic center. So any neutral species where pi bond is present between different atoms, it will act like a electrophile. And so these two are electrophiles. These two are electrophiles. And if pi bond is present between same atoms such as alkene, alkyne and benzene, they are known as nucleophiles. So pi bond between different atoms, electrophile, pi bond between same atoms, nucleophiles. Alright. Now, if we have to figure out which one will be a better nucleophile, which one will be a bad nucleophile, so how we figure out that? So in a protic solvent such as water, ethanol, carboxylic acid, we can figure out nucleophilicity on the basis of below points. If a negative species is present, it will be a better nucleophile than its neutral form. Example, OH minus is a better nucleophile than water. NH2 minus is a better nucleophile than ammonia. OH minus is as compared to SH minus, which will be better. Always remember that bigger the central atom or negative charge containing atom, better is the nucleophile. So negative part is better nucleophile. Next comes in a period. If you check out in a period, what happens is, for example, CH3 minus, you have NH2 minus, then you have OH minus and F minus. If donor atoms belong to the same period, then basic character is equivalent to the nucleophilicity. Here you can see that basic character is maximum in fluoride, then OH minus, then NH2 minus and CH3 minus. So the nucleophilicity will also have the same order. So across the period you can say nucleophilicity increases from left to right. Now if you have nucleophiles belonging to the same group, I minus, Br minus, Cl minus, F minus, in a group, in a period left to right nucleophilicity increases, in a group nucleophilicity increases down the group. So I minus is a better nucleophile than Br minus, then Cl minus and F minus. So nucleophilicity always increases down the group and increases across period. Alright, so these are few examples we have discussed how you can figure out which is a better nucleophile and which is a poor nucleophile. And if some bulkiness is there, for example I have CH3O minus, I have another one CH3 CH3O minus, what do you think which will be a better nucleophile? I think a smaller one you will say will be a better nucleophile because this will have high steric hindrance, bigger size, high steric hindrance, high steric hindrance. The steric hindrance is the hindrance caused due to bigger size. So out of these two, this will be a better nucleophile. Smaller one will be a better nucleophile. If you have bigger groups, steric hindrance will increase and nucleophilicity will decrease. So this is it about nucleophiles. Thank you.